Alright, hi you guys. Today in Pre-Calculus A we'll be talking about graphing sine and cosine functions, and they're very similar. Now, as you've already learned in Algebra 2, when you started to graph this stuff, you started to learn some of the finer intricacies. Okay, my highest recommendation is to just go ahead and start using everything you can on Desmos. So if you're not using Desmos, please do. Okay, so number one thing, you need to go over here to this side and make sure that the graph settings, the x-axis is in steps of pi, or you can put pi halves if you want, so you can type in pi. Yeah, let's just leave it at pi. That's a good one. Okay, leave the y-axis in terms of steps of 1 or 2 or however you want to set it up. Let's go ahead and make that a 1. There we go. Okay. All right. Now, you want to make sure your angles are in radians, because if you try to graph this stuff without radians, you're going to make a huge mistake. All right, so let's look at some properties of this. So y equals sine of x. And you're going to be using x. You could use theta if you want. You know, it's totally up to you. But as you can see, theta doesn't work here. You actually have to go down here to your function bar. And I believe it would be, well, it's a good thing I went down here, because oh, there it is. You could type it in like that, and they will recognize that theta. Okay? Alright, so that theta right there. So as we type it in. Now, some things to notice about this, and we're only going to focus, and let's actually focus on, let's go, whoops. Let's go from negative pi less than or equal to theta. Now let's just go ahead and make this an x, which is x, which is less than or equal to pi. Okay, let's get rid of this, move it over. There we go. So we'll just look at this portion for right now. Okay, some things to notice. Sine graph starts from 0. It goes up to pi halves, comma 1, down to pi, comma 0, and it repeats over and over again. So this is just one period or one wavelength of sine. Now, its x-intercepts, if I go ahead and get rid of this part, let's just graph a different one, y equals sine of x. Okay, now if I zoom out and look at this, its x-intercepts are always going to be, and this is without a phase shift or anything, its x-intercepts are always going to be the multiples of pi, going in both directions. Okay, so it's really kind of cool how it works out that way. Okay, you guys? So some really cool stuff to just work with here. Alright, so that one is that one right there. Let's zoom back in. Okay. Alright, now its major period is from pi halves to negative pi halves, and just works that way. Okay, its amplitude is always going to be a 1 unless you put a different number in front of sine. You learned this back in Algebra 2. Okay, alright, and its frequency, its entire period is going to be the length of 2 pi. So this is pi right here. Believe it or not, this is a length of pi here, so 1 pi plus 2 pi equals 1 pi plus another pi equals 2 pi. Okay, so when we're looking at cosine, it's pretty simple like this. Alright, now when we're looking at cosine, okay, you're going to be looking at this one right here. Now the reason why it's not really showing up right here is, well, it's pretty much the end, so let's change it up. Let's change this to 0. And let's change this to 2 pi. There we go. Okay. Now this is the typical motions for it. Okay. All right. So cosine will start at the 1 on the y-intercept, and it will start to go down and then come back up into the hill. So for those of you guys who are Tiny Wings fans on your iPhone apps, you'll recognize this hill right here. Okay, all right. Now, its x-intercepts, if we take a look at the bigger picture and zoom it out, it's going to appear at every odd pi halves marker. So notice 5 pi halves, 3 pi halves, negative pi halves, negative 3 pi halves, negative 5 pi halves, and so on and so on. Okay, so when we're taking a look at this, when we're looking at cosine, we're just looking at the x-intercepts being right there. Okay? All right. Now, its wavelength or period is also a length of 1. Okay, and its amplitude is also 1. I'm sorry, its period is 2 pi, the same as before, except you can actually see the 2 pi where it's going to start repeating the pattern. Okay, and its amplitude is just going to be a 1 up and a 1 down for an amplitude total of 1. Okay, now its range is always going to stay between 1 and negative 1. Its domain for both of them is going to stay between them. Now, if I put these two right next to each other, let's go y equals sine of x, and let's get rid of these. If you notice, it not only does it look like a double helix, okay, not only does it look like a double helix, if I could get these x-intercepts to stop popping up. Not only does it look like a double helix, but it looks like, here's the cosine wave. The cosine wave is either the sine wave shifted to the left pi halves units. Look at that. It's exactly pi halves. From the top of one to the top of the other, it's literally a difference of pi halves. Or it's a sine wave is a cosine wave shifted to the right pi halves. So it depends on your preference, and that's what we call phase shift. Okay? All right, so now let me see. There we go. Let's open this bad boy up. And we will just focus on these two. Okay, now talking about the transformations. Once again, amplitude, the number in front controls the amplitude. If you make it negative, obviously it's going to flip upside down. It's typically just 1. All right, now B and H will control the phase shift. Okay? All right, so B actually controls the period. And I believe the formula is in your book. I believe it's 2 pi divided by b. So you take this number and you divide it into 2 pi for cosine and sine. Okay? And then h, you could change the phase shift right there. So that's actually really kind of cool. Normally h is just 0. Alright? And if you change these, you can change how it moves. And as you can see, it moves a little bit slower if I make B bigger. If I make it really big, H is going to move really slow. No matter how big I get it, it's going to give the appearance of moving slow right there. So it's really kind of cool how B and H work together. Now if I change K, this is the vertical shift. Obviously it just changes up and down. Okay. Alright. So be very careful how you work with this one. Now please understand, whatever you do right here, use Desmos to find the intercepts, especially x-intercepts, and just work your way across, okay? Now this one, the x-axis is in terms of not pi. I'm going to change that real fast. And the y-axis is in terms of, should be 1. There we go. Now it looks a little bit easier to read, okay? All right. But that is pretty much everything you needed to know about the graphing and understanding of how the graphs of sine and cosine work. So if you have any questions, please feel free to call me. Okay.